Now let's discuss about Chinese remainder theorem. Okay, so that means you are going to factorize the denominator to get the answer. Let's take a number for that. 1 2 3 1 2 3 1 2 3 etc 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 300 digits. Okay, so it's a bigger number. 300 digit means I'll get a 1 2 3 group for 100 times. Okay, so 100 such groups are there. Now the question is divide by 99, what is the remainder? So here you can write this 99 as 11 into 9, right? So basically you can factorize the denominator as 11 into 9. Okay, now in this type of question, what you need to do is, if you are factorizing the denominator, what you need to do is, to solve this question, this is a bigger number, right? So what you will do is, you will make it as a smaller number but a similar number. Now how you are going to do it, I'll tell you. What you need to do is, you divide the bigger number, the numerator. First you need to do, this is the n, right? N. You divide n by 11, see what is the remainder. Then you do n by 9, then see what is the remainder. Okay, so here you get one remainder, here also you get one remainder. Based on that, you will find a smaller number but a similar number which satisfy both the condition. Let's see how you're going to proceed. So let's do this step first. N by 11, what is the remainder? Divisibility of 11, you have enough flexibility in this case. You can either group it into a group of 1, group of 3, group of 5, group of 7, group of 9, or whatever way you want you can group it, right? So here, rather than grouping it into a group of 1, you can group it into a group of 3, because here 50 positive groups are there, 50 negative groups are there, both will get cancelled and you'll get remainder 0. 50 1 2 3 groups which is positive, 50 1 2 3 groups which is negative, you'll get remainder 0. Then you need to find the remainder when divided by 9. So what is the divisibility rule of 9? Sum of digit till you get a single digit. Let's take sum of digits of the first group. You get 6. 100 such groups are there. That means 600. 600 again, if you take sum of digits, you get 6. So you got, what is the 0? 0 is the remainder when divided by 11. And what is 6? 6 is the remainder when divided by 9. So now I'm going to rewrite this n. N I'm going to rewrite. We have seen this enough in the case of division chapter, and we had enough discussion, we have solved enough example, so you need not have any confusion here how to write n and all, right? So n you can write it as, when you divide by 11, right, you get a 0 remainder. The same number when you divide by 9, you get a 6 remainder. So what we did, this number when we divide by 11, you have no remainder. This number when we divide by 9, you have a remainder of 6. Why this A and B? A and B are two quotients, and two quotients are different because the divisors are different. Okay. Now, to apply Chinese remainder theorem, what Chinese remainder theorem says is, you just take a smaller number which satisfy both the condition, and then you can get the remainder faster. That will be remainder here, or your remainder depends on that number. Okay. So let's see a smaller number which satisfy this condition. It will be anywhere less than 99, because this divisors are 11 and 9. If you take the LCM, that is 99, so it will be anywhere less than 99. Let's do it. Okay, so what you need to do for that, first you take this one and write the series. What are the possible numbers in this? Okay, 11 is the first possible number because 11 by 11 remainder 0. Next possible number, it will increase in steps of 11, right? So next will be 22, then will be 33, then will be 44, then will be 55, etc, etc. It will go. Now after this, what you need to do, you take out this series, right? 11b plus 6. How many numbers will satisfy this condition, or what are the numbers which will satisfy this condition? What are the numbers which will satisfy that condition? First number will be 6, because 6 divided by 9 leaves a remainder 6. Now it will increase in steps of 9. That means 15, 24, 33, 42, etc, etc, etc. Now if you see here, you get a common term here. So 33 is a common term. What does it mean? If you divide 33 with 9, if you divide 33 with 11, you get a remainder 0. If you divide 33 with 9, you get a remainder 6. So 33 is a smaller number but similar number. Why? Because it satisfies both the conditions. Because I got my n 1 2 3 1 2 3 1 2 3, which I can rewrite it as 11a plus 0 9b plus 6. This 33 also I can write it in the same way, 11a plus 0 and 9b plus 6, right? So 33 is the similar number but a smaller number, and your remainder, according to Chinese remainder theorem, your remainder is this 33 itself. You just need to find that smaller number and similar number. If you need to do, you need to divide it by 99. But basically you will get 33 only. The smaller number if you divide by 99, you will get the remainder when the bigger number divide by 99. So here it's 33. Now why it is working, that also you need to know. It is based on constant remainder theorem that we have already discussed in AP, but let's go for a quick recap of what we have done, right? So if you see here, 33 is the first number. That is a smaller number but similar number. Why I am saying smaller number and similar number? Because this is the least number which satisfy both condition. What are the condition? 11a plus 0, 9b plus 6. So this is the least number which satisfy the condition, least possible number. We had enough discussion in division question, right? What is the next possible number? How to get it? You add LCM to it. You add LCM to it, you will get the next number. What is the third number? You add LCM to that. So if you keep on adding, you will get this. You will get a series, or basically you will get an AP with the first term 33 and a common difference 99. Now this thing we have already discussed. Any question which can be asked in an AP can be asked here. They can ask you how many such terms are there. They can ask you 10 such term, n such term, first term, common difference, etc. can be asked. But let's confine to this question now. So first term is 33, next is 9, next will increase in steps of 99. So let's write the series, right? So first is 33, it's not required for this question, you already got the answer as 33, but I'm just explaining the logic why you got it, right? So 33, then you add 99, that means 132, you add 99 again, 231, then 330, right? Then 429. Now what are these numbers? These numbers, when you these numbers will satisfy the condition anyway. When you divide by 11, 0 remainder. When you divide by 9, 6 remainder. All these numbers satisfy the condition. Now, what is the common difference? That's what I told you. Common difference is 99. Common difference is 99, right? Now here also 99. Basically common difference is 99. It's an AP. First term is 33. Common difference is 99. Now, what is constant remainder theorem? If you have an AP, okay, if you take out any term from the AP, divide with the common difference, the remainder will be same in all cases, right? Any term if you take, you divide with the common difference, you get a remainder. Any other term if you take, you will get the same remainder, okay? You can take any term from the AP, you can divide by 99, okay? You will get the same remainder. Here, first term you take, 33, divide by 99, what is the remainder? 33, right? Now you take any term, let's take 429. Divide by 99. What remainder you are going to get? You will get 33 itself. You take 330. Divide by 99. What remainder you are going to get? You take 231. Divide by 99. What is the remainder? Again 33 itself. Now if you continue, basically if you continue this series 33, 132, 231, 330, 429, if you continue this, you will end up in getting this number, right? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 is a part of the series. Somewhere you are going to get this number. So that number also if you divide by 99, what will be the remainder? 33. And that is the logic that we used. So what all things we did here? We based a Chinese remainder theorem, and to understand that I just explained you the constant remainder theorem. Now let's take one more example. Okay, I'll take a number as 1, 2, 1, 2, 1, 2, etc, 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 up to again 300 digits. Okay, what does this mean? You have 150 groups, right? One group means 1, 2, 1, 2, 1, 2, 1, 2, like that. You have 150 groups are there, right? So this is your n is given. Now divided by 99, what is the remainder? Instead of 99, you can take it as 77 or whatever you want, you can do it, not a problem. Okay, I'm taking it as 99. So I am factorizing. So then what you need to do, you can factorize this denominator as 9 into 11, right? Now what you need to do, you can divide n by 9, see what is the remainder, right? Then n by 11, see what is the remainder. So you get a condition here, you will get a condition here. Based on that, you can find a smaller number but a similar number which will satisfy both the condition, right? And that will be your remainder when the bigger number divided by 99. That's what Chinese remainder theorem. Or that number will actually help you to find the remainder. That number, let's take, you get s divided by 99 will give you the answer. So let's see how you proceed. You can start n by 9, right? See what is the remainder. It's based on divisibility of 9. So what is divisibility of 9? You take sum of digits. So if you see here, 150 times 1 is there and 150 times 2 is there. So if you do this, you get 450. 450 is nothing but 9. If you add, you get 450, which is nothing but 9. So when you get 9, what does it mean? When you divide by 9, 0 remainder. That's what we understood, right? So when you divide by 9, 0 remainder. Now we need to see 11, right? Now if you see the remainder when n divided by 11, how will you do? 150 times 2 is there, okay, minus 150 times 1 is there. you get it as 150. Now divide it by 11, see what is the remainder, you get it as 7. So what you got, when n divided by 9 you get 0 remainder, when n divided by 11 you get 7 remainder. Now based on this you can rewrite n. You can rewrite n, and based on that you can find a smaller but a similar value of n. Okay, now how will you write n? N is equal to, we have seen when divided by a, divided by 9 leaves a remainder 0, right? So 9a plus 0, which is also equal to when divided by 11 leaves a remainder 7. So you'll write it as 11b plus 7. Now we have solved enough problems based on this. So what you need to do now, to find the smaller number or the least possible number or the smallest such possible number, we take out this and see what are the possible numbers, right? You need to do it manually. The first possible number is 9. 9 by 9 you get 0 remainder, right? Next it will increase in steps of 9. It will be a multiple of 9, right? So 18, 27, 36, 45, etc. it will go, right? Now if you write this series, what it will be there? It will be, first number will be 7. So 7 by 11 give you remainder 7 itself. Now it will increase in steps of 11, right? Next will be 18, next will be 25, but here I got the common term. Now when I get the common term, what does it mean? This satisfies both the condition, right? 9a plus 0 and 11b plus 7. So what was the n which is given to us? 1, 2, 1, 2, 1, 2, 1, 2, 300 digits, right? So here what we got is 18, which also satisfies both the condition, right? 1, 2, 1, 2, 1, 2 up to 300 digits will satisfy this condition. When divided by 9 leaves a remainder 0, when divided by 11 leaves a remainder 7. My number, smaller number 18 will also satisfy the condition. Divided by 9 leaves a remainder 0, divided by 11 leaves a remainder 7. So I can write 18 as the first number. What will be the next number? Next number, if you need to find out, you need to add LCM, right? So you add 99, you get 117. You add again 99, you get 216. You add 99 again, you get 315, etc, 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 etc. It will go, and somewhere you will find this number. What? 1, 2, 1, 2, 1, 2, etc, etc, 300 times. Now you know, based on constant remainder theorem, if you pick any number from the series, any number if you pick from the series, divide by the common difference, get the same remainder. Okay, constant remainder theorem. So you take this number 18, divide by 99, what is the remainder? 18 itself. So that itself will be the remainder, 18 itself will be the remainder here, 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 and anywhere in the series, and for this also. So to find the bigger number divided by 99, you can use this method, 18 divided by 99. So in both cases it will be same. This is what Chinese remainder theorem. So we can apply it easily to find the answer, right? So 18 is the answer for this question. Quick recap, what we did, we got n is equal to 1, 2, 1, 2, 1, 2, etc. 300 times, right? So what we need to do, we need to find a smaller number but a similar number. And how will you find it? You have a denominator 99, you factorized it as 9 by 11, 9 into 11. Now you do individually, right? Bigger number by 9, you see what is the remainder. So n is equal to 9a plus 0. You got that, right? Then you divide bigger number by 11 and rewrite n, right? So you wrote it as 11b plus 7. What does this mean? I have an n, I have a number, this number, which when divided by 9 leaves a remainder 0, which when divided by 11 leaves a remainder 7. So what is the minimum possible value of value which satisfies this condition is what I need to find out now. How do I find it? I did it manually, right? I find the series, I found a common term which is 18. So 18 satisfies both the condition. 18 means when I divide by 9 leaves a remainder 0, when I divide by 11 leaves a remainder 7, right? So my answer will depends on 18. So 18 by 99 will give my answer. That is 18 itself. Now what is the logic? Logic is what I have explained, right? Because this is going to make an AP with 18 plus 99k. So you have a first term as 18 and a common difference of 99. You're going to get an AP, right? So any term if you pick from the AP and divide by the common difference, reminders will be same. Any term if you pick from AP, divide by common difference, reminders will be same. So whether it is first term or the last term, remainder will be the same. So here first term is 18, divide by 99, what will be the remainder? 18 itself. So one of the term is 1, 2, 1, 2, 1, 2, 1, 2, etc. 300 times, you pick that, you divide by 99, then also you get remainder as 18. Constant remainder theorem. So we are following both Chinese remainder theorem, constant remainder theorem. So let me conclude. We'll solve all the problems in a different session, problem solving session. We'll discuss all the scenarios, we'll solve all the problems. After that, we'll take up all the CAT questions from 1990 onwards up to 2017. We'll solve all the questions, right? So here, what we have done till now, we have discussed a basic remainder theorem, we have discussed Fermat theorem, right? And I've also told you how to apply Euler's number to make this concept easier. We can get the reminders in a seconds, right? Then we have seen 2 raised to n numbers, how to find the remainder. So in all these cases, what you're doing, you are factorizing the numerator. Then if the denominator is larger, then I told you what we have done is we have applied Chinese remainder theorem, right? So we factorized the denominator and we applied the Chinese remainder theorem, we got the remainder. So then we have seen denominator factorization, or I can put it as Chinese remainder theorem. Here also I discussed about constant remainder theorem also.